Hello, aspiring Java developers. Person with folded hands, welcome back to our channel. Today, we are diving deep into a very powerful and essential concept in enterprise Java development, Java EE CDI, which stands for Contexts and Dependency Injection. If you are building robust, scalable, and maintainable applications, understanding CDI is absolutely crucial. It helps manage your application components, making them loosely coupled and easy to test. In this 5-minute tutorial, we will explore what CDI is, how it works, and how you can leverage it in your projects. We will cover the core annotations like @inject, @producer, and @qualifier, look at a practical example, and discuss some common mistakes to avoid. So, grab your virtual notebook, and let us get started on this exciting journey. Alright, let us start with the very first core concept, the @inject annotation and CDI beans. A CDI bean is essentially any plain old Java object, or POJO, that CDI manages. These beans are the fundamental building blocks of your application. The magic happens with the @inject annotation. When you mark a field, a constructor, or a method parameter with @inject, you are telling the CDI container, hey, I need an instance of this type here. The CDI container then takes on the responsibility of finding an appropriate instance of that class and providing it to you automatically. This process is called dependency injection. It means your class does not need to worry about creating its dependencies, it just declares what it needs, and CDI provides it. This significantly reduces boilerplate code and makes your components much easier to manage and test. Think of it like ordering food at a restaurant. You just specify what you want, and the kitchen prepares and delivers it to your table. You do not need to worry about cooking it yourself. Now, let us move on to customizing how CDI provides dependencies using @producer methods and @qualifier annotations. Sometimes, the objects you want to inject are not simple CDI beans, or they require special initialization. This is where @producer methods come into play. A method annotated with @produces tells CDI how to create an instance of a particular type. For example, you might need to produce a database connection or a configuration object that needs specific setup. The @produces method will return the instance, and CDI will manage its lifecycle. What if you have multiple implementations of an interface, and you want to choose which one to inject? That is precisely the job of the @qualifier annotation. You can create custom qualifier annotations to distinguish between different implementations. When you inject a dependency, you can specify the qualifier, guiding CDI to inject the correct implementation. This provides powerful flexibility and allows you to swap implementations easily without changing the consuming code. Let us put these concepts into practice with a simple e-commerce service example. Imagine we are building a shopping cart that needs to process payments. We will define a payment service interface. Then, we can have multiple implementations, say, credit card payment service and PayPal payment service. Now, in our shopping cart class, we want to inject a payment service. How do we tell CDI which specific implementation to use? This is where @qualifier shines. We will define custom qualifiers. for example, at credit card and at PayPal. We annotate each payment service implementation with its respective qualifier. Then, in the shopping cart, we use @inject along with the desired qualifier, for example, @inject credit card payment service. This way, our shopping cart class remains decoupled from the concrete implementation, and we can easily switch payment methods just by changing the qualifier at the injection point. This demonstrates the power of CDI for building flexible and maintainable applications. As you begin working with CDI, it is important to be aware of some common mistakes and follow best practices. A frequent mistake is trying to @inject into a class that is not a CDI managed bean. Remember, CDI can only inject into objects that it manages. Another pitfall is forgetting to specify a scope for your beans, which can lead to unexpected behavior regarding their life cycle. Always consider the appropriate scope, such as @request scoped, @session scoped, or @application scoped, or the default @dependent scope. A best practice is to always prefer injecting interfaces rather than concrete implementations. This promotes loose coupling and makes your code more flexible and easier to test. Also, understand the life cycle of your beans. CDI provides annotations like @postConstruct and @predestroy for initialization and cleanup logic. By keeping these tips in mind, you will write more robust and efficient CDI applications. And that brings us to the end of our 5-minute deep dive into Java EE CDI. We have covered what CDI is, how @inject helps with dependency injection, how @producer methods allow custom instance creation, and how @qualifier helps disambiguate between multiple implementations. We also looked at a practical example and discussed common mistakes to avoid. Remember, CDI is a cornerstone of modern enterprise Java development, promoting loose coupling, testability, and maintainability in your applications. The key takeaway is to embrace dependency injection to create modular and flexible code. Now it is your turn to practice. Try implementing a simple service using CDI in your next Java EE project. If you found this tutorial helpful, please give it a thumbs up, share it with your fellow developers, and do not forget to subscribe to our channel for more advanced Java programming tutorials. Keep coding, keep learning, and I will see you in the next video. Namaste.